In this video, we're going to solve the following problem. Linda invests $15,000 into a bank account, earning 7.75% interest per year with monthly compounding. We want to estimate how much the account will grow between 2 and 2.2 years. So this suggests we should be using differentials. So let's see how that works. So we want d future value is equal to future value prime, the derivative, times dy. And we know dy is the difference between 2 and 2.2, so that's 0.2 years. And we want to calculate the future value, the derivative, at 2 years. Okay, so in order to do this, of course, first we need to write down what the future value is, given a number of years. So just generally, the future value at some time t in years in the future is 15,000 times 1 plus, we're compounding it monthly, so 0.0775 divided by 12 to the power 12t. Okay, now we don't yet know how to take this derivative, so I'm going to do a little bit of simplification or change the equation a little bit so that it's in a form that we know. So our problem right now is this 12t. So this is like some number to the power t, except we've got our 12 there. So I'm going to rewrite our equation. Future value at t is 15,000. And so this is just using properties of the exponents, and we're going to get, so let's put a couple of parentheses here, 1 plus 0.0775 divided by 12 to the power 12, all to the power t. Right, so if we've got an exponent which is a product, we can take one of those numbers, the 12, inside, and then raise that to the power t. Now we can take the derivative because this is just some number to the power t, and we know if we've got f of x equals b to the power x, then its derivative is b to the power x times natural log of b. So we can take our derivative here, fv prime of t is 15,000, that's just a constant, times, and again, let's just write it all out, we'll be careful here, 1 plus 0.0775 divided by 12 to the power 12 to the power t, right? That's that first term, b to the x, times natural log of 1 plus 0.0775 over 12, and inside, oops, let's put an extra parenthesis here, to the power 12. And now we can just rewrite this a little bit, clean it up. Fv prime of t equals 15,000 times, and this is just this original thing, so 1 plus 0.0775 over 12 to the power 12t, and this we can bring the exponent down, so we get times 12 times natural log of 1 plus 0.0775 over 12. Okay, the future value, we don't need this, but we'll calculate it. The future value in 2 years is $17,506.14. The derivative, this is the instantaneous rate of growth in 2 years, is $1,352.36. And the approximate, when we're estimating, we're doing using differentials, so the approximate amount that the account will grow is dfv is fv prime of 2, instantaneous rate of growth, times dy, which is 0.2. So that's 1,352.36 times 0.2, which is $270.47. Okay, so again, just reviewing, we took the derivative, we needed to calculate differentials, so we need the derivative. We took the derivative, now we had to use a trick. Eventually we'll learn a slightly easier way to do this, but right now we used a trick. The trick was to recognize that if you've got, I'll write it out here maybe, if we've got a to the power x times y, that's a to the x to the power y. So that's the property of exponents that we used in this step here. That left us with a function whose derivative we can take, right? So we know if we have a function b to the x, then we can take its derivative b to the x times ln of b. So we took its derivative, we did a little bit of work simplifying, and then just plugging in numbers, working through to calculate that we estimate the account will grow by $270.47 between 2 and 2.2 years.